computer. Ooh. Oh yeah, subtitles. Ooh, how do I do that? Do you know? That's right. You were asking about that. It's going to be a new challenge for me. I've never done live subtitles. That might be something I need to learn about. Ah, okay. Well, great that maybe you don't have any questions at the moment. That's actually a good sign. I mean, you know what's going on. So, but oh, let me write that note to myself. Live subtitles. How do I do that? I do know this, that subtitles, when I process it and put it on YouTube, the subtitles are there. So I know the recording, the subtitles are there, but how to do them live? I think you were asked, or either you were asking or the DSP counselor, somebody was asking me if I had any live, Zooms. And I was saying, well, I have help sessions that are live, so I need to learn how to do it, but I don't have any lecture material. So, and by the way, that's the second thing I wanted to say. So besides putting any questions you guys might have in the chat, put or know this, that this is a help session. So it's if you have questions, that's what I'm here for. If you don't have any questions, and people will pop in and out all day long. So sometimes I get questions right away, and other times I don't. So feel free to pop in anytime. In fact, as long as it's being recorded, like I said, subtitles will be added to this when I put them on YouTube. And then let me just check the time frame here. And it's the same I said in my email, but we'll start here at 10, go till around 11:30-ish. That'll be a good time for a break. We'll take an hour break, come back at 12:30, and then go for another hour and a half. So what does that make it? 2 o'clock, and take another hour break, come back at 3 o'clock. Now, the exception for today, I can't come back at 3 o'clock, but normally on Friday, we'll come back for a third time and keep working until 4:30, or really until questions are done, which sometimes that's before 4:30, and other times it's later, sometimes quite a bit later, usually right before a test. People have a lot of questions, so we go really long. So that's kind of the layout. Now, I do want to give some priority to anybody in 121 and 102, because I know these help sessions can get really dominated by people in 122, and rightfully so. Their material right now is super hard, and the other classes are just beginning. And not to say, or not to understate them, but they are kind of on the easy side here. So I usually get, and I say usually, of course, I've only been teaching this way one time until last fall. So this is my second time through it, in at least 122. I should clarify that, because the 102, I've done a few times online, because we've done it in summers and we've done it both semesters in fall and spring. But that's just a long way of saying here that I will answer any question at any time from any of the three classes. Gladly do that. And like I said, to get them into a fair order, throw them into the chat. That's the best way I can keep track of them. But that aside, the best thing I can do is to give a priority. And I wrote it down here. Yeah. So that from 10 to 10:45, anybody in 102, I'll throw them to the top, and anybody in 121 at 12:30, just for your efficiency. All right. Yeah, I don't see any subtitles. I can't hear them. Let's see. Yeah, I was hoping there was a button down here on Zoom that said live subtitles. And I don't see any. I hate to start this way, but I might have to say that I might not have subtitles for you until I get it posted on YouTube. And then sometime I will make sure, maybe on the break, I can contact, oh, it's in the advanced, okay. Advanced, in the advanced meeting option. And now is that something I have to set up before I start the meeting? Because wouldn't be under security, would it? Not 100% sure. I just Googled it. No, breakout rooms, reactions, chats. One thing I think of is security. Doesn't seem right. I'm getting a strong feeling that in the account settings, I have to do that before I start the meeting. I know that let's see. I know that the homework, these are different questions, are submitted on the first day of the exam, but are the labs just due Sunday? Well, let me answer that question. That's better than I can do than the subtitles. But are the labs just due on Sunday of the week they are assigned? So yes, the labs will be due each Sunday. So your first lab, at least for you guys in 122, I should make that real clear. So Lucas, for 122, you have a lab this week, and that's due Sunday. And that's the only thing that's officially due to turn in. Of course, you've got your homework, and I would encourage you to do your best to finish up that homework by Sunday. This first chapter is very, very difficult. So it wouldn't surprise me if half the class didn't get it done. That's kind of the norm. So, but they will get at least close. And so I'm going to encourage you to, finish it up, get close if you can. And then it's not officially due until we start or until the test day. So you got plenty of time to turn it in still, but you should ideally be finishing it, because next week we'll start the next one and do the next one. So you only have a 122 lab due. Okay. Now, if anybody's in there in 102, let me say that we don't do a lab this first week. So you really don't have anything due onto Canvas this week. Your first lab will be next week. Your homework is also due on the day of the first exam, so it's not really due until the first exam. But again, to keep on pace, let me encourage you, for you 102 people, you should finish up that homework by the end of this week. And there really is no reason you shouldn't, because it's not a hard one like the 122 class. It's the 102 class. You should be able to finish homework 1 and move into a little bit of 102. As you saw, I posted 2 of the 4 lectures. So. All right. Hey, this got me curious. I've only communicated so far one way and through the chat with the questions. Can anybody unmic themselves and just say hi? So I know that A, you hear me, and B, I hear you.
I hear you. Hey there.
Okay. Great. I got a wave too. Okay. So I hear one of you.
Hello.
I got 2 of you responded. Oh, good. And I got another hi from Johnny.
I can hear you too.
Oh, Okay, good. Oh, and you unmuted. Okay, great. So three of you. All right, good. And that's okay. I just wanted to double check that. Um, so that seems to be working good. So for those of you who might have popped in, I'll just say the same thing. If you have a question at all, throw it into the chat. That's the best way for me to keep things organized. Of course, there's just a few of us right now. I don't know if that's a good sign or a bad sign. Maybe the homework was so easy, nobody needed any help. But you could also just say it verbally at this point. But definitely keep it in the chat too, so that I can keep track. And again, I'm still scanning around here. If I can start subtitles, I'm going to on our first break, but know this, that I will definitely do the subtitles. When it posts, that's part of the processing of it. So, anybody have a specific question? And I know there's always some confusion at the beginning, so I'll just make it clear that these Zooms are extra help. They're not required. They are that hopefully you've worked through the homework during the week, and any questions that you have, this just gives me a way to be more face-to-face, more personal with you, and say, all right, hello, and what are you guys struggling on, and kind of get a pulse of what's going on, especially you guys in 122. You guys are on some tough material right now. So who's in 122? Okay. Who's in 102? Right. I got two of you, and I think Johnny, you're in 121, aren't you? And Fiona,
I'm in 122.
22. You were 121 last time. That's why I got you. Yeah. Okay, so I got two in 122, two of you in 102. All righty. And so again, like I said, if you have a specific question, throw that in the chat. Love to do that together. I haven't used my Zoom or phone since spring, so looking forward to kind of doing a problem with anybody who's got one. And I'll say it again, this is the priority time for 102. So you two who are in 102, if you've got any explicit questions, fire away. Know that you've got first choice, and the others of you, I'll work with that. So, but if nobody's got a direct question, I guess maybe I should throw the question back at you guys. Maybe I'll do one at you two in the 102. How's it going? Are my instructions clear enough? Do I need to send out more clarification? I mean, any feedback would be great both ways, I'm sure.
I'm wondering, for the conceptual questions, what's the height of a typical person? What are you supposed to, do you want to show calculations, or do you just want?
Yeah. Thank you for bringing that question up. You're the first one to bring it up this semester, but I get it all the time. There's a whole series of questions like that. It's like, what's the typical weight? What's the typical size of a baby? What's the typical size of a human? Okay. So, or a size of a room. There's a bunch of those like that. Know this: the intent of that problem is not really any kind of calculation. That one, for whatever reason, always throws students a little curveball. They're like, well, what? I don't get this. And so let me explain. The intent of that problem is to see if you understand a little bit about the size of a centimeter and the size of a meter. Okay, so if it asks for the typical size of a human, and I think that is the one that says in centimeters, or maybe it says meters.
I think it was in centimeters. Most of them, I think, with the height are in centimeters.
Okay, so I'll just kind of hold my fingers here. So, they want you to realize that this is about 1 centimeter. So if you were to answer at 1 centimeter, that would be wrong. Okay.
Mhm.
Because clearly a human is much bigger than that. Okay.
Mhm.
And then, of course, 100 centimeters would be a meter, which is a little over 3 feet. So just to say 100 centimeters is not a good answer. I wouldn't say it's wrong, but you're kind of, meaning you're kind of understanding what a centimeter is. So probably a good answer is, and they're, 150, 160, 170, all those would be acceptable answers. 300, again, you're kind of, that's 10 feet. There aren't any human, so you're shaking your head. So you get it.
Yeah.
And so there's a bunch like that. I think another one asked for the weight in kilograms of a typical human. And again, 1 kilogram would just be wrong. It's just too small. And 1,000 kilograms would be too big. Even 10 would be too small, but 100 is probably a little big for a human, but it'd be an acceptable answer because it's telling me that you kind of have an idea of what a kilogram is.
Okay. Thank you.
Don't make a big deal out of those, but that's why they're there.
So my question was also on chapter 1.
Uh-huh.
And when I checked my answers against yours or the ones you provided,
Yeah.
I noticed that I'm trying to remember what number it was, but I noticed that on some of them, I went all the way down to a specific number and then you left it at like an equation looking answer. So how would I know when to stop?
Okay, that's definitely not an easy thing to know. And so maybe I should start with saying there is no right or wrong place really necessarily to stop. There are some traditions, and so maybe that's the way to say it. There are some, I'll say, norms. Okay, and it's gonna, let me see if I can find anything that you were exactly talking about, because the norm would depend on which problem you're asking about. So was it, I don't know, can you give me any more helpful guide of what problem it might be? Oh, and of course you said you were looking at the solutions, right?
Yeah, I'm looking for it now. I had it
Okay.
in mind, but then now I've moved on to chapter 2 and now I can't remember which one it was.
Okay.
But that was kind of where where I ended up having a problem. And then also same thing with the conceptual questions. I didn't know if there is a traditional way of breaking down like the process of going from the imperial system to the metric system. I don't know if there's like a set process. Like for instance, like when I think of time, I think, okay, an hour, I can break it down into minutes and then seconds. But when I think of going from, meters to miles, I don't know what that process is in between.
Okay. Actually, that's a great question. Oh, good. And give me a chance to write down here. Oh, and I forgot to mark what time I started the recording, but it must have been about 19 minutes ago. Oh, 19 minutes. I'm going to just say here, unit conversion. And then, oh, good. So you're going to be the first time I've done this in a few months. Great. I'm going to share my screen. Here we go. Share. And, oh, I didn't get this before, but that's okay. It says I have to install plugin. Okay, that looks good. All right. now, there we go. So screen share. All right. Oh, how come it kind of miniaturized it? Oh, okay. Good, good. Okay, so you guys, I think you can see. Can you see my pad of paper here? All right. Okay. Good. Other than adding a plug-in, it worked again. I like it here. All right. So let's see. That was G, right? I go back to the. Let me say this. Let's say I had how about for the sake of discussion, 1.25 miles. So I think that was kind of your statement here that, okay, if I have so many miles, how would I change that, say, into meters, going from the English system, as you said, to the metric system? I like to explain it this way. If you were to multiply by 1, you still have the same distance. Maybe I'll even put same. And here then is the clever way to get the number 1. And maybe I'll just go to the top of my paper. If I had something like 5/5, well, that's 1. If I had A/A, well, that's 1. Okay, so here's, I think what you're trying to say is kind of the traditional way of doing this is to say, okay, what could I put here that would be equal to 1 that would change miles into meters? Now, I don't expect you to know this from memory, but you could look it up in the textbook or Google it. There is 1,609 meters in 1 mile. So those two are equal, okay? A 1 mile is the same as 1 meter. So watch what happens if I do this. What if I put the number 1,609 meters in the numerator and 1 mile in the denominator? First, to notice that those two are equal, so that fits what I was saying. I'm not changing the length. I'm just multiplying by 1. And then notice that mile would cancel with mile, and I would be left with just meter in the numerator. So that's the strategy, if you will, of how you do something like this, is to find a clever one such that you will get rid of whatever you're trying to get rid of, miles, and retain whatever you're trying to get into. So the key is to find what you're trying to get it into and what you're trying to get rid of. And what you're trying to get it into, you put at the top. What you're trying to get rid of, you put at the bottom. And if they're equal to each other, then you get just the number 1, and you get where you're going. So if I finish this calculation just to find out, it'd be 1.25 from that number. And then I multiply by 1,609. And in this case would be 2,000, and I'll just round it up to 12. No, doesn't round up to 12. Rounds down. So 2011. So, and I can do some more if you want, but was that what you were looking for?
Yeah. Yes, thank you. But my question, to further the question and my
Yeah.
understanding. So if it's not asking in meters and it wants kilometers, I always just start with the meters and then just do the conversion into kilometers, or
Okay.
is that true?
Yes, and you could do the metric system. I mean, the one I was showing you, going from the English system to the metric system, I think it's harder than what your second question is
No,
here.
I'm sorry. I'm sorry. I think I'm not sure that I asked correctly. So yes, I did want to know, because we are working on the metric system. I did want to know miles to meters.
Yeah.
But if, for instance, the question was to convert it into kilometers,
Oh,
then
Oh.
I'd still want to do the meters jump, right? That's still like my intermediate step.
yes, unless, well, yes and no. I mean, I would say most likely yes, because this connection is easy to find. However, if you had this, I'll just kind of start the problem again. If you had looked up kilometers to miles, then you don't have to do the intermediate step. So that may not be listed. But if you had that step, you would not need to do the intermediate step. You would just write what you want to get it into, which is 1.609 kilometers, and that's equal to 1 mile. And then that would go right into kilometers. However, I think most likely although this isn't hard to find, so this is probably a bad example, but you most likely will find this conversion, not this conversion. So if you don't have that conversion and you know that one, then, as you said, you have this first step. And now you have to do a step that converts it into kilometers. And so 1,000 meters is equal to 1 kilometer. So if you do the same thinking, I want to make this equal in the top and equal in the bottom. I want to get it into kilometers. So I'll put that in the top. I want to put what it's equal to in the bottom in the same units that would cancel off. Then I would get this 2011 divided by 1,000, which is 2,000 or 2.001 kilometers. So if you, again, don't have this big step that you really want, and you have to do an intermediate one, you've got to do this multiplied by 1 2 times. Yeah. Am I getting closer to understanding your question? Okay. Okay, good. And then some of these, and I know you didn't ask this, but just for you and anybody else who might be out there, if you had a big conversion, let's say I gave you a distance of 14 feet. Well, you might do something like this. Maybe the first thing to do is to convert feet into inches. And so this ratio here, I want to get rid of feet. So I'll put that down here and I'll put what's equal to it in inches above it. So that would get rid of feet and convert it into inches. Now, the reason I picked that one is because a very common conversion in the metric system is 2.54 centimeters is 1 inch. Oops, 1 inch. So those are equal. And so that would be multiplying by 1. And then that would change your inches to centimeters. And then maybe the question was asking for it in meters. So I would do one more step and say, okay, I want to get rid of centimeters. So I'll put centimeters down here, and I want to get it into meters. So I'll put that up there. And I know that 100 centimeters is equal to 1 meter. So that would get rid of my centimeters. So again, that same logic being, I'm multiplying by a 1, a 1, and a 1. And so I really haven't changed it from its length of 14 feet, but I've changed it from being in feet to inches, and inches into centimeters, and centimeters into meters. And so the final answer here would be something that would look like, I guess, this 14 times 12 times 2.54, then divided by 100. So I'll just go two significant figures. 2.3 meters would be the answer for something like that. So good general question. And then of course you've got a few of those on homework 1, but as you said, it sounds like you've figured them out and are moving on to the start of the physics in chapter 2. Good for you.
Yeah, I had to Google them,
Okay.
like the conversions.
Yeah. And just as a side note, it's kind of early in your education, but it's never too early to memorize a few things, but never should memorize too many things. When people try to memorize just way too many things, it overwhelms them and they forget it. So I'm a big fan of trying to memorize fundamentals and basics, and then from that, everything else is deductive reasoning. So what I mean by that is it would be unnecessary to memorize this conversion, which is from English to metric, or metric to English, whatever you want to say, and also this conversion. They're both a conversion of length. So I would say memorize one of them, not both of them, because you can always derive the other one from the one you've memorized using this little strategy. So, and the one to memorize is actually this one. This one is exact. The 2.54 centimeters is exactly equal to 1 inch.
Okay.
Whereas this up here, it's actually 1,609 point something. And I don't know what that something is. I would have to look it up, but I could figure it out from this one. So I encourage students to memorize one of the length conversions, and this is the one I emphasize. So, but at this point in this class, let me point out that I don't require you to have memorized it. If you get something in the English system, and you won't very often, but if you do, feel free to Google it or look in your book to convert it.
My last question before I run out of the fast pass is the chapter 2 answers. I don't see them. Where can I find them?
Oh, did I not send you the whole link that listed all of them?
Unless I missed it, but I don't think so.
Okay, so let me.
You did. You sent a link and then you click on it and then it'll show the different chapters and you have to choose. So if you go to the email he sent and then click it, I think it'll show the different chapters and then click on the chapter you want. At least that's what worked for me. I'm not sure if, I don't know.
Okay, and I'll send it right here in the chat also. So here it is. So it's that link in the chat there. I don't know if you can see it in the chat.
Okay, got it. Where is this on Canva? It just
Oh, yeah, no, this actually, it's not on Canvas. This is just our web server. Before these days of COVID, I never used Canvas, so I had all these things posted on our web server, and I probably should. Well, I guess it is in the syllabus or the announcement. So technically, you can get there from Canvas. If you look at the first announcement and read it, you'll see that there's a link, and then you can click on it, and it'll take you there. But
Okay, thank you.
this, yeah, just putting it there in the chat was probably the easiest answer I can give you right now.
Okay, thank you. And I found the 2 questions. I don't need you to go over them because you already answered that, but I'll put them in the chat if you want to go back and look at them. Or if you want to know which ones they were.
No, I'll do a pass if you don't need them. This is for you.
Okay.
So
Okay.
if
Thank
anybody
you.
else wants to, I'll encourage them to put it in the chat. All right, let's see here. So maybe I will. Let's see. How do I stop share? Good. I'll stop share for a moment, for better or worse, to see if give me a chance to see all your faces on one screen, and then also scan the chat here. So good. I don't see anybody, but as a few others of you came in, let me just say the same thing. This is, it's for you. So I want to just kind of answer and have any questions. I guess it's also for me. It's good to actually see students. I like that. So, but if you have anything that is an explicit question for, that's what I want to take this time to address. And Monday through Thursday, you're kind of working a little bit more independently and on your own. Now's my chance to
Hey, Michael.
see what communication I missed out. Hello, yes. How do you pronounce your name? Can't we?
Just Sasha. You can call me
Sasha?
Sasha.
Okay.
Yeah.
Nice. Okay.
So I'm kind of trying to do 41 on my own, but it was just kind of a question about I'm in 122, by the way.
Okay.
It was about the electric fields, like in the problem setup. They didn't give me an image for problem 41, but they're describing it to me, like the electric field that this particle is gonna pass through or whatever. It has this initial velocity. It's about to go into an electric field. And it says it enters a uniform vertical electric field.
Okay.
So does that mean that the positive has to be in other images? There was like the positive on top and like the negative, those 2 bars or whatever, and the vertical kind of arrows pointing.
Right.
Or could it be like negative on the top and positive on the bottom? Doesn't matter at all.
Well, yes and no. And if you want, I would like to just kind of work through the whole thing, and we'll start with your question with the field. Let me jump over to the questions. This is 122, and you said number 41.
Yep.
Let me do a reshare here with my phone. I guess I shouldn't have necessarily turned that off. I'm a little out of practice here, but while that's coming back into play, there we go. I'll just write down. Okay, so Physics 122, Chapter 23, number 41. And here they have, and let me just read it for myself here. It says a proton is moving at this speed in the horizontal direction. So I'm going to start by saying I would do something like this. I'd say, okay, I have a proton moving in the horizontal direction. I'll put a number here, 4.5. times 10 to the 5. It enters a vertical electric field that has magnitude. Oh, and for your class, I like to be color coded. Let's see, he uses kind of a burnt orange. Let me dig these
Yeah.
back in. So
Blue is negative, and then what was it? Orange is positive or something?
yeah, he uses a bunch of colors. Yeah, he uses orange for positive. He uses kind of this orange also for the electric field. So this is pretty close to the red I was using, but I'm going to just do this. Let's see, does it show up on the screen? Okay. It might be kind of hard to say that's a different color, but I'll try to be a little color coordinated with this class because it really helps, and that's why. But notice, by the way, then it says that the electric field is vertical, but I'm not going to put any arrowheads here. I think that was part of your big question: is what direction is this one? So I'm going to keep reading here. I am going to put down the number. It says it has a magnitude of 9.60 times 10 to the, and I believe that's a third. I need to make my screen a little bigger. Times 10 to the 3 newtons per coulomb. Ignoring any gravitational effect, find the time required for the proton to travel 5 centimeters horizontally, its vertical displacement. Maybe it is trying to say which way it is. It says it enters a uniform vertical. All right. I'm going to take that to mean they are saying the electric field is pointing upward. Enters a uniform vertical electric field. Okay. Now, I think part of your question was, and correct me if I'm wrong here, you were kind of interested in what was creating this electric.
Well, it was more like, so you saw for part A how it asks for the time.
Yeah.
And that doesn't really have to involve the vertical part yet at all. Actually, it just involves with the horizontal
Okay.
aspect. But then when I came to part B with the vertical displacement, I was just like, oh, what sign should I put on for the delta Y or whatever when I was.
Okay. So if I'm hearing you right, you did A already and you're satisfied with that.
I think so, yeah.
Yeah, because you could just say something like, velocity in the X direction is the change in position in the X divided by time. And that, of course, goes back to physics 121.
Right.
And just for completeness, let me finish this up so I can have this number. Usually they're needed in the future, but this says 5 centimeters. So I'm going to put the distance in meters and the velocity is already in meters. So that the meters will cancel off and you'll be left with seconds. And so it'll be 0.05 divided by 4.5 times 10 to the 5. And that would be 1.11 times 10 to the negative 7 seconds.
Yep. Yeah, I got that too.
Okay.
Cool.
So then your next piece, it says the vertical displacements And then again, grabbing an equation from, I guess this would be physics 121. And if you say it's moving along, and let's call that starting vertical position 0, the fact that they say it is moving horizontally means it is not having any velocity in the vertical direction.
Right.
And then the acceleration in the y direction would be the force in the y direction divided by mass. And then the force, at least the magnitude of the force, because I think this gets to the heart of your question. I'm just going to do magnitude of the force would be the charge times the electric field. So that's the new piece for this semester. But I'll say that the direction of that force would be the same as the direction of the electric field, which I'm going to say is up. I think the author could have done a better job of saying up. He says vertical, so I'm going to take that to mean he meant vertically upward, not vertically downward, because something could be vertical pointing down and something vertically pointing.
Yeah. Yeah.
In fact, since you bring that up, I'm going to jump over, and maybe you already said this, to the solutions. Yeah, and he does everything up in terms of positive numbers in the solution.
Okay. Okay.
So, and that sounds like that's the major part of your question.
Yeah.
But I'll also, for completeness, if you will, rearrange my pad here, punch these in. And so 1/2 times the charge of a proton, 1.602 times 10 to the negative 19. Then times the electric field, which is this 9.6 times 10 to the third. Then divided by the mass of the proton, 1.67 times 10 to the negative 27. And let me pause. I've got that one memorized because I've done it so many times, but know that you don't have to have it memorized. You can just look there. And the front of the, it's the front cover or the first page or second, third page of the textbook in the PDF. It's there. But of course, today with as we're all online and you're Googling it, it's, however you want to get the mass of the proton. So
Yeah, sure.
it's fine.
I
Okay.
usually just type it in and I find out on Google.
And then good. And then times the time we got before, 1.11 times 10 to the negative 7, and that's squared. And so this is 0.00. And let's see, how many significant figures should I use? They gave 3 here.
3 for the charge, right?
And they gave 3. Yeah, so it looks like I should do 3. 5.67. And if I look at my units here, the electric field times the charge. So that would be a coulombs and then times a Newton per coulomb. Mass was in kilograms and seconds squared. So coulombs would cancel. A Newton, if you remember, is a kilogram meter per second squared. So the kilograms would cancel and then the second squared would cancel. And so not a surprise, the end of this is in meters. And so if I do one more step and convert it into millimeters, moving the decimal 3, I'd get 5.67 millimeters.
Oh, is that what that? Yeah, I should have changed that then. It asks in
Um,
millimeters.
And again, you don't have to change it to millimeters, but I bet the author does. Let me check. Yeah, see, in his solution, he changes it to millimeters just because, having a bunch of zeros is not very comfortable. So the general practice is to switch it so that you kind of have something in the units that kind of gives it a first or second decimal or something like that.
Okay. Yeah.
But that's not a big to do. Good.
Yeah, and then there was also a part C there.
Okay. Yeah, I'll move on. See here. I just wanted to check because if there's any way I can get these captions, I'd love it. And I see that in the text, it said Zoom doesn't seem to be able to caption in real time. Oh, and say you don't know how to write a conceptual question. Is it a question from the homework? You can just tell me the number and I'll look it up. Or one like it. But you know what? I'm not so sure we can't do captions in real time. I thought the DSP office allows us. Or maybe I should put that in the chat. I will check with DSPS. I think they have a program to let me do real time caption. Yeah. Yeah, so if you that might be the best thing I can think of until I can contact them. Yeah, write it out and I'll screen share with you. Okay, so let me finish this question for you. Yes, you're right. There is a part C to this. Part C. And I will need to jump over part C, get back over here. Okay, it says, so find the horizontal and vertical component of the velocity after it has traveled this. All right. So same idea, starting with going back to physics 121, the velocity in the x direction is equal to the initial velocity in the x direction times the acceleration in the x multiplied by time. And for the x direction, the initial velocity that was given, that was the 4.5 times 10 to the 5th. And they did not have an acceleration in the x direction. There was no force in the x direction. I know that because the force is equal to charge times the electric field. And so when I write this as a vector, they are saying that the electric field is only in the vertical direction, which means I only have a force in the vertical direction. So getting the velocity in the x direction is pretty easy. It doesn't change. There is no acceleration in the x direction. And then for the y direction, it would be the initial velocity in the y direction plus the acceleration in the y direction times time. And the initial velocity in the y direction is 0. Again, just like in part B, they made that very clear when they said it starts out purely horizontal, so it has no vertical velocity. Then the acceleration would be like we did before. It would be the force in the y direction divided by mass. And the force in the y direction would be the charge times the electric field divided by the mass multiplied by time. And so if we put these numbers into our calculator, so this would be the charge 602 times 10 to the negative 19 for the charge. The electric field, let's come back here. That electric field was right here, 9.6 times 10 to the 3. Let me divide it by that mass again, 1.67 times 10 to the negative 27. And then multiplied by the time we got, which in part A, so 1.11 times 10 to the negative 7. And that would give me a velocity of 1.02 times 10 to the 1, 2, 3, 4, 5, 6. No, 5. 1, 2, 3, 4, 5. 5. And again, looking at the units, these were coulombs and newtons per coulomb. This is mass in kilograms, and this is time in seconds. So coulombs would cancel, but also a newton is that kilogram meter per second squared. So the kilogram would cancel and also one of the seconds. And so you'd be left with meters per second for velocity. And did that finish the question? Let's see, the horizontal and vertical components. Yeah. And there's a lot here. Let me just check. So did I get that one right? Good, I did. And that one, good. All right. So match with the other. Nice. All right.
Yeah, I kind of like that problem. It's a bit of a confidence booster, in my
Good.
opinion.
Good. All right. Let's see. Okay, thank you. Tomorrow, mail to you. Okay. All right. Yeah, let me just answer her here. Okay, so So I'll screen share with you right now if you would like. Just yeah. I'll have to give you permission, so let me know if you want to screen share. Let's see.
Are you talking to me?
No, not yet. Here, hang on.
Okay, no worries.
That Brendan? Yeah. Let me know what you'd like. All right. Okay, so that being said, all right. So with that being said, let me just come back here and scan the chat. Okay. Okay, I don't see another question. And know that if anybody's in 102, I guess technically, as G put it, we're past the fast pass time, but that's okay. I think I should extend it a little bit if there's anybody out there, but let me actually check that here. Who all do we have here? Is that oh, okay. So anybody have a question for me? Something I should address?
Yeah, I just sent a problem to you in the chat.
Oh, you sent it in the chat, you say?
Yes.
Okay, let me go back. I might have looked past it.
I just resending it again right now.
Oh, you sent it in again? Okay, then I won't go back and scan it. I'll just wait for it to come in.
Oh, whoops. I think it was in the private chat, actually, just straight to you.
Oh, does that come in a different place? I would have thought it would come to the same. Oh,
Okay, I just sent it to the regular one anyway.
okay. Oh, yes. This is an interesting one, and the answer itself. Let me just point out here. Oh, and by the way, Brendan, earlier, I mean, if you just want to tell me what number, I'll be that works too, and I can just
Gotcha.
jump over and read it myself. You don't have to type out the whole question, unless you want to. Your choice. But yeah, this one says, and I'll just read your question. It says 2 people at arm's length had 1% more electrons than protons. Carry out an order of magnitude calculation. Now, this is not intended to really be an exact answer problem. This is designed really to show you how incredibly strong these electric forces can be, because most materials have an equal number of protons and electrons. And because of that, forgive me, let me just pause here for a second. 1 hour and about 1 minute into the recording. This is, I just want to write down what question this is so I can index it a little better. I think this is the first one, isn't it? Yeah, number 3. Okay. Perfect. This one was carried out, and as they say, that the great scientist Richard Feynman, what he was trying to do was trying to use an example here for students to realize how incredibly strong these electric forces are compared to, say, gravity, or compared to well, I'll just say compared to gravity, but compared to the forces we're used to, a push and a pull. And we don't really realize that because the number of protons, positive, and the number of electrons, negative, are almost so equal that they tend to balance each other. And so he says, what if it was just 1%? So let me do something like this. All right, so chapter 23, problem number 3. Let me take maybe a stick figure person that is an arm's length from another stick figure person. And so order of magnitude, I'm going to say they're 1 meter apart. That actually might be even pretty big. I guess I can't put my hand really on the screen there, but if I were to reach out and shake somebody's hand, let's see what word he uses in the question. He once said that if 2 persons stood at arm's length. So 1 meter would be okay. Part of me wants to kind of cut it down to 3/4 of a meter, just because I'm kind of looking and saying, well, if I put kind of 2 arms together, it wouldn't quite be a meter. But this is kind of minor. This is not a big deal. So whether you want to call it 1 meter, he does say order of magnitude. So order of magnitude means to the closest power of 10. And so closest power of 10 would be 10 to the 0 power, which is 1. So maybe I should just use the 1 meter, even though I think that might be a little long. I'll follow the phrase that says order of magnitude. Okay. Then here, of course, it says an arm's length and 1%. Okay. So here again, we got to think about a human a little bit and say, what is the mass of a human? Again, order of magnitude. Humans are somewhere around 70 kilograms. They're in the 60s, 70s. I mean, some can be down in the 50s, some can be high into the 80s, I realize. But I'm just going to take a rough number. Again, order of magnitude, you could call this 10 to the 2, that's 100. That might be a little on the high side, but again, if I'm going to follow my order of magnitude rule, I should probably just call it 100 kilograms. Now, here's where a little previous science knowledge has to come in for this problem. If you look at an atom, why don't I just take like a simple atom, but not too simple? How about helium's a good one to look at? Hydrogen's the simplest one, but it's so simple that it doesn't always show all the features of an atom. So I'm going to kind of draw helium. And helium has a nucleus with 2 protons and 2 electrons and an equal number of electrons. And so the point I want to get at is roughly the number of protons and neutrons are the same, and roughly the number of electrons and protons are the same. So because they're trying to get me to figure out how many electrons. And then again, a little bit of background science here. Electrons are about 2,000 times lighter than a proton. I think the number is closer to, if I remember right, 1,836. Okay, but again, rough order of magnitude. I'm just going to say this, that when it comes to the mass of a person, forget the electrons. They're just too small to consider. So if I were to do this, if I were to take the mass of a person, so about 70 kilograms, and divide it by the mass of a proton / neutron, because they have about the same mass. They're not exactly the same. I think one of them is 1.67. I think the other is 1.66. So they're really close. But if I just did this quick division here, this would tell me how many protons and electrons are in a typical human. Okay, so I'll take 70 and divide it by 1.67 times 10 to the negative 27. All right, so a typical human has about 4 point, and I'll just go 2. Again, we're just rough numbers, times 10 to the 28. So again, the 4, I don't know if it's necessary. We can just carry it or not, but there's the order of magnitude. There's the times 10 to the 28. Now, technically, I should divide that by 2 to get the number of protons. Because again, this is the number of protons and electrons that are in a human body. Okay, so this is about 2.1 times 10 to the 28, and I'll just say protons. So that's how many protons there are. Now, as I said earlier, this is also the same number as electrons. Okay. Now, if I take 1% of them, so 1% means multiply by 0.01 times how many we have. Okay, so that would be about 2.1 times 10 to the 26. So that's about how many electrons they're talking about in this problem when they say 1% more. So we have this many extra electrons, and it's a huge number, 10 to the 26. So if you want to know now, and this is the big step, the charge, the extra charge, in other words, how much more negatives does this person have than positive? This is the extra electrons. And I will take this many electrons. Maybe I should just spell it out, electrons. And multiply it by the charge of one electron. And so this will get me to the main part I need to get to figure out the force between them. So the charge of this person, and it would actually be both people, grabbing my calculator here, 2.1 times 10 to the 26 times 1.602 times 10 to the negative 19, I would get 3.36 times 10 to the 1, 2, 3, 4, 5, 6, 7 coulombs. So that would be about, if I move the decimal, that's 33 million coulombs if I put it in words. So that's how much charge this person has. All right. So we were asked, or we are asked to, let's see, is it the force they want? Yeah, the repulsion force between them. So they're like charges. And so let me just put here where this chapter started. Force is Coulomb's constant times charge 1 times charge 2 separated by the distance between. So the repulsive force would be something like this, 9 times 10 to the 9th. And the units here are Newton times meters squared over Coulomb squared. So that's Coulomb's constant. Then the charge of the two people. And so 3.36 times 10 to the 7 coulombs is kind of our rough estimation or order of magnitude of, okay, how much charge does this person have? The other person has the same amounts. And they are separated by, and now we can come back to here, how much accuracy do we want? Again, I think a meter might be a little far, but it would be very reasonable to use a meter. I'm going to go with the 0.75 as long as I'm getting out my calculator anyways, kind of a judgment call. And so none of this is, like I said, strict accurate numbers, they're order of magnitude. And of course, you can see that the square meters cancels off, the square coulombs cancel. Oops, I forgot to put one here. Cancel off. And you're going to be left with a force in newtons. And so grabbing my calculator, I can go 9 times 10 to the 9th times 3.36 times 10 to the 7th. And the same number again, so I'm just going to hit square and then divide by 0.75 square. And it looks like 1.8 times 10 to the 25 newtons is kind of my rough ballpark number here of what I would get. Now, out of curiosity, since this is a rough ballpark, I don't need to match the solutions exactly at the end, but it looks like the author got a 10 to the 26. Looks like we differ. Let's see, he had 3.7 here. So he got a few more electrons. Oh, I see, because he got a few more protons. He took a little different approach. Now, it's interesting, he took the same mass as a 70 as I was guessing, but he took an approach of saying we're mostly water. And the reason that's interesting and probably a better one is because water is made of oxygen and hydrogen. And oxygen has 6 protons and 6 neutrons, whereas hydrogen only has 1 proton and 1 proton. And the reason I'm getting at that is he's going to get a number a little bigger than me and probably better. So I probably should have done this because he's going to get 8 protons and 6 neutrons in water. And I just kind of took a rough ballpark that there's an equal number of protons and electrons. He did not do that. And so his is going to be a hair higher than mine. And sure enough, it was. Oh, and he also did a little shorter distance. Anyways, so again, 10 to the 25th or 10 to the 26th is both acceptable. And the whole point really isn't an accurate number. The whole point is to get you to realize something really important about this physics. And that is these electrical forces are enormous. And just a small percentage, 1%, would be such a huge number. I mean, to humans this close, that'd be enough to push them off the surface of the earth and send them into outer space. So this is an enormous force. And so it is extremely rare. No, well, I'll even say never happens on the earth where you have, 1%, of the electrons extra or missing. That's just an overwhelming. When we charge something up, we add electrons or we take electrons away, and that number is a small percentage, not even close to 1%. Not even close to 0.1%, not even close to 100%, not even close to 1,000%, not even close to 1,000,000%. It's just incredibly small compared to the number that they have. But still, a reasonable amount of force. So that's the intent of the problem. Hope that helped.
Yeah, I did. Thank you.
Okay.
I think that's why I was so confused. I didn't realize how much like information we just have to like infer by ourselves, like the weight, like how many, the ratio of protons and electrons.
Yeah.
Used to like the problems, like giving them the information you have to work with, you know.
Yeah.
But yeah, that helps. Thank you.
Good. Yeah. You're right. I should have recognized that. That's really what students have a trouble with that. They're like, well, what did I miss something in the right reading? And then like, no, you didn't miss anything in the reading. They just want you to estimate it. And in fact, I think before you popped into the Zoom here, there was 102 students who were doing some ballpark calculations, and they were essentially asking the same thing in a little different way. So anyways, good. All right.
Hey, Michael,
Yeah.
do you mind if I ask you a question unless it's someone else's?
No, go ahead. Like I said, my first priority is the chat, and I don't see anything new in the chat. So go ahead, fire one off here.
All right, great. It was number 45 on 122.
Okay, so chapter 23, number 45. Nice. And let me write that down. Number 45, and we are at about an hour. Well, 23. Start a little late. Let me put an hour 20. Got to be a little more careful on starting my clock here. I'm out of practice from last spring. Yeah. And in fact, well, in this class this one is a harder one here. So I'm out of practice from last fall. Okay. But that being said, let's do that and see where that gets us. It looks like probably by the time we finish one will probably go long. It sounds like a good one here. 45. Let me scroll on down. Oh, yes.
When I was looking at it, I was kind of tricked probably because I thought it was not that difficult. It definitely involves forces, but yeah, I didn't account for the tension. And then like, I was like, oh no. So we don't know the tension yet. And I can't find the,
Yeah. All right. Let me run through this one here. We have a charged cork. It has a mass of 1 gram. It's suspended from a light string. And they give us this uniform electric field. And they list the number here. Okay. And the ball is at an angle of 37 degrees. All right. Now, part of this problem, like actually the earlier one, is there's a lot of physics 121 stuff in here that needs to be reviewed or remembered. And I'm going to start with the free body diagram here. Because if I take this little, what they call it, a charged cork ball. So I take this piece of cork and I look at the forces going back to physics 121 and free body diagrams. I know that there is the force pulling it down, mg, and everything touching it. And so that would be the tension in the string. Let me put in my diagram the 37 degrees. Okay. Of course, maybe just to complete it, they list the angle up here as 37 degrees, but I'm going to use some geometry. Those are alternate interior angles, so that would be 37 degrees. And what's new then is there would be an electrical force. So these are the two forces, and we would have probably run out of forces and stopped if this was physics 121. And so what's added to it is the fact that there is a force here, which is the charge times the electric field. And this charge is unknown. However, I'm hoping you can kind of see from our physics 121 that this tension here has an upward vertical component and a left horizontal component. So that would mean that if you're going to balance this, you have to have a right-leaning electric field or electric force, I should say. So this would be a force in the x direction. And there would also be a vertical one, but let me hold off on the vertical one because it's this step here that tells me that the Q has to be greater than 0 because I need a force to the right and the electric field has a component to the right. And when you look at this equation here, this equation tells me that the force is in the same direction as the electric field for positive charges. But for negative charges, I put a negative here. That would tell me the force is negative or opposite of the electric. Okay. So since I know I have to have a force in the x, the positive x direction to balance the component of the x from the tension, that is my first step in figuring out what this charge is, knowing that the charge has to be greater than 0. And since I know now the charge is greater than 0 and the vertical component of the electric field is up, I am then going to have a vertical force. So the total electric field force is like that. It's the same direction as the field. That's what this little equation says, because I am multiplying by a positive number times that electric field. So that's going to give me a force that is in the same direction as the field. And I didn't write it in my page here, but let me do that now. The electric field is 3 I hat plus 5 j hat times 10 to the 5 in units of newtons per coulomb. Okay, so there's my 3 forces: the gravitational force, the tension force, and the force that is new this semester, the electric force. All right, but going through kind of the same strategy of 121, where I got to look at the x's and the y's separately. Since they said it's at equilibrium, I know the sum of all the forces in the x direction is 0. And I also know that the sum of all the forces in the y direction is 0. So again, this is the part that I was saying is we've got to go back to physics 121 here. All right, so if I look at the x component, I would say, well, and I'll just go around in order. There is no x component from the weight of it. Okay. The x component from the tension would look like this. It would be the tension, and it would be the opposite of the 37 degrees, and it would be in the negative direction. So there is the x component of the tension. Now, the x component of this electrical force would be up here. It would be the charge times the x component of the electric field. So charge times the x component. Okay. Well, the x component is 3 times 10 to the 5. And I didn't give myself
Yeah.
enough room. So there's a 0. Now, that equation has 2 unknowns. So I'm going to have to go over here to the y component to have something interesting. But I'm going to simplify this a little bit. I'm going to leave the q and the 3 times 10 to the 5 alone. I'm going to get out my calculator and check if I'm in degrees. Good, I am. And I'm just going to put the sine of 37. And I'm going to call that 0.602 times the tension, that number, and then move it to the other side. And so maybe I won't put a box, but I'll put a little dotted line around this because this is going to be, I think, very useful. But it's my first equation, but with 2 unknowns, so can't go any further with it. I've simplified it as much as I could. But now let me go over to the y component. All right. So for the y component, and I'll just go in that same order. The first one is its weight, and that's down. So that's all y, so that's a negative mg. The next one, the tension has a y component. It's upwards. So I'll put plus, it'll be t, and it is adjacent to the 37 degrees. So I'll put cosine of 37. There's the vertical component. And also the vertical component from the electric, so this is the new stuff here today, would be the charge, so there's Q, times the vertical electric field, which is 5 times 10 to the 5. And that has to equal 0. Maybe I will simplify a little bit and then put these together. So I'll go the cosine of the 37. So that is 0.799 tension plus Q times 5 to the 5th. And then I'll move the negative mg to the other side. And I'll even put that number in. I do know that. And that was, let's see, what did they say the mass is? What, 1? So 1 gram. So let me put it as 0.001 for the number of kilograms times 9.8 comes out to be 0.0098. And let me put a dotted line around that. I'll give myself a fresh piece of paper. Looks like I've got quite a bit of algebra to do now to answer this question. So now I'm in a good mathematical spot. Now that I've done the physics, I have my 2 equations and 2 unknowns. And the first question is A, find the charge, and the other one's find the tension. And I guess it doesn't matter which one I do first. So maybe right here, I'll just say Q then is equal to 0.602 T over 3 times 10 to the 5th. And I'm going to use that into here. So this is 0.799 T plus, and in place of Q, I'll put 602 T over 3 times 10 to the 5th. And then this is times 5 times 10 to the 5th. And then that equals 0.0098. And of course, the whole idea of this substitution was now we have everything in terms of T. In fact, the 10 to the 5th cancels off. That'll save me a little bit. And I'll just do this one first, 0.602. If I multiply it by 5 and then divide by 3, that's pretty close to a 1. So that's a 1t. I'm going to add it to a 0.799. And so this is 1.80t. And so t equals, and so I'm going to go 0.0098 and divide it by that last answer. And I get a tension of 0.00544 newtons for one of the answers. And then knowing that, I can solve for Q. Okay, so here's the tension, and so I'm going to multiply it by 0.602 and divide it by 3 times 10 to the 5th, and I will get a Q of 1.09 times 10 to the negative 8 coulombs. So it's one of those problems that A, has quite a bit of math, 2 equations, 2 unknowns, gives students troubles. B, another trouble because it goes back to physics 121. And then, of course, it also has a new piece here. This is this new force. And I see it's past our break time, so we'll break after this, but let me just make sure. The number was just 45. I want to check the answer and see what he get for Q. He got, now he writes it as nanocoulomb. So he makes this one bigger, which makes this smaller. And then 10 to the minus 9 is a nanocoulomb. So he writes it as 10.9 nanocoulombs. Okay, good. So we agree there. And then over here, he writes it as 5.44 times 10 to the minus 3 newtons. And a minus 3 is a milli. So it would be 5.44 millinewtons for the force. And yep, sure enough, that's what he writes there too. Nice. Nice.
Great. Yeah, thank you.
Okay, good. Hey, so when we come to the end of the first break, what I like to do is see what questions are still in the chat so that I can start after the break with those, but I don't see any. So, all right, so we're doing well here. So let's take a little a break, and there'll probably be other people who come back in the second session. The 121 people might show up in greater numbers there because they've got priority during that time. On the other hand, they're starting with some pretty simple stuff, so they may not even have some questions. And I already sent them some video solutions. Anyways, all right, guys, it was good working with you. Take a little break. I'll see you back at 12:30, so in 50 minutes, okay?
Okay, thank you.
You bet.